All right, in this video, we will go over the sample exam 2. All right, we're going to start with computing the derivative of these functions. Let's remember a few things. Well, we know that'll be the power rule, but anytime we take the derivative of some exponential function that doesn't have e as the base, it's going to be that same exponential function times the natural log of 3. Right? And we do know that the derivative of tan of x equals secant squared x. So let's try these. We're going to take a, where f of x equals x to the third plus 3x. And he says don't simplify, which is good. So the derivative equals the derivative of this first part, which is just the power rule, plus the derivative of the second part, which is 3 to the x ln of 3. That's all that is, okay? Now, b requires us to use the chain rule, right? We have the tan of the sine of x. So there's our chain rule, the inside function. So the derivative of the outside function is secant squared of sine of x times the derivative of sine of x, which is cosine of x. And that's the answer. Right? We want to not get it too complicated. You know, he's actually given these are rather doable. Okay? Now, this C uses the quotient rule, which is if you have something f over g, it's f prime times g minus g prime times f over g squared. So let's try that. All right, f prime, right, times g minus this f times the derivative of g, which is 1, all over x squared. If we wanted, those could cancel out. We could write 1 minus the natural log of x over x squared. All right? Determine the interval where this function is concave down. So we have to get to the second derivative, right? So if f of x equals x to the fourth minus 4x to the third, we have to take the first derivative, and this is the power rule. 4x to the third minus, the 3 comes down, 12x squared. All right, then I take the derivative of that, I get 12x squared minus 24x. Now, I always like to find out where it's 0 and figure it out on the number line. So if I try to figure out where it's 0, what I'm going to do here is actually factor it. I'll pull out a 12x, right? And I'm left with x minus 2. Well, this is 0 at 0, and it's 0 at 2. So on our number line, I have a 0 and a 2. That means at these points, it's an inflection. So my second derivative, right, is 0. So I'm going to find out where that second derivative is negative, if it's concave down. So let's see what's, oops, I got 2 on the wrong side there. So let's switch these. This is 0 and 2. So let's see what's happening at 1. Here's my second derivative. So 12 times 1 times 1 minus 2, that's 12. Right? So this is negative in here, isn't it? But we're going to check on this other side. We'll check 3. 12 times 3 times 3 minus 1, so that's 36 times 1. That's positive, right? And if we check negative 1, we'll have 12 times negative 1 is negative 12. Negative 1 minus 2, that's negative 3. So this will be positive when I look at the signs. So the interval over which it's negative is from 0 to 2, not including. All right? All right, find all points on this graph where the tangent line is either horizontal or vertical. Okay, I wrote this. We learned that we need to take the derivative. When the numerator of that derivative, and this is implicit, right, is 0, you'll have horizontal tangent lines. When the denominator is 0, you'll have vertical tangent lines. So, x to the third plus y to the third minus... All right, so let's do this implicit differentiation. 3x squared, all right, plus 3y squared dy dx. Now I have to do the product rule, don't I? minus the derivative of x times y plus x times the derivative of y, 2y, dy dx. So far so good, equals 0. So this is minus y squared minus 2xy dy dx. So I want to solve for dy dx. So I'm going to subtract this over to the other side, and I'm going to add this. So what's left is 3x squared minus y squared equals, I'm subtracting this over and I'm adding this over. So negative 3y squared dy dx plus 2xy dy dx. Alright, factor out the dy dx. I'm just going to pull it out of here. Right? And then divide by this. And I'll just change the order because I like to put the positive first. 2xy minus 3y squared. Alright. So, dy dx should equal, I'm just making sure, y squared, I have the same thing as the professor. I just have a, if I pull a negative out of both of these, they'll cancel and I'll look like his. So, alright, so what I'm going to do is I'm going to come up here, because we know that we have to set the numerator equal to 0 to find the horizontal tangent line. So the numerator looks like this. 3x squared minus y squared equals 0. 3x squared equals y squared. And we're going to solve for y. If I take the square root of both sides, y equals 3x. I didn't do that very well. X squared. So y equals plus or minus x times the square root of 3. Alright? Well, we have a relationship there. Now we have to figure out the different points. Right? So when y is equal to x square root of 3, we plug that right into our original equation. Alright, x to the third plus, this thing to the third is x to the third 3 square root of 3 minus x, y squared. Y squared would be x squared times 3, right? Equals 5. Okay. This is a whole lot of fun. So basically, he wrote this as x to the third plus x square root of 3 to the third minus 3x to the third. So see how we have this x to the third theme going on? Equals 5. X to the third minus 3x to the third. So I'm going to do this x, and that'll be minus 2x to the third. Right? Let's factor out x to the third. If we factor that out, x to the third, we hit, oops, and it's not a radical, I'm factoring it out. Inside the radical, I will have, if this thing is to the third, it's 3 square root of 3 minus 2 equals 5, right? Divide by this, 3 square root of 3 minus 2. So x to the third equals this thing, and then I got to take the stinking cube root, right? So it's 5 over 3 square root of 3 minus 2 to the 1/3, which is the cube root, right? So I'm going to get rid of some of this, if I can. Using my eraser stylus. So we have found that one of our points will be x is 5, 3 square root of 3 minus 2 to the 1/3. And because x is written in y is written in terms of x, I'm going to take this x and I multiply it by the square root of 3. So then y will be the square root of 3 times this, 5 over 3 square root of 3 minus 2 to the 1/3. Phew, that's kind of tough. Now you know we're doing the same thing using y equals negative x square root of 3. And when you do that, you end up with, for our x, it's the same thing, except now we have a negative 3 square root of 3 minus 2 to the 1/3. Right? And then this would also be square root of 3 times 5 times 3 square root of 3 minus 2, the negative to the 1/3. So those are 2 points where we have horizontal lines, right? Now if I take all this stuff and I'm going to move to a thing at the end here, and I'm going to try it here. So now we figured out that dy dx, I'm just taking it off of his sheet now. It's the same as mine with just a sign change, but it won't matter. Y, 3y minus 2x. Now, to find where the tangent lines are vertical, we set this equal to 0. Whoops, not multiply times. So, y equals 0, or 3y minus 2x equals 0, 3y equals 2x, y equals 2/3 x, right? Excuse me. So when y, we're going to take this point and this point. So when y equals 0, we go back to our original equation, which was x3 plus y to the 3rd minus, right? And that's 0 and that's 0. We get x to the 3rd equals 5. So x equals the cube root of 5. All right. X equals the cube root of 5. So that means this point is 5 to the 1/3, 0. Now we can do the same thing using the 2/3 x, right? So take our original equation, x3 plus 2/3, x to the 3rd, right? Minus x times y squared, which is 2/3 x squared equals 5. We're doing the same theme. We're looking for these x squared. So we have cubed, x cubed plus 8 over 27x cubed. This would be minus 2/3 x cubed. So far, so good? These are kind of nuts. Equals 5. So we have a 1 plus this plus this. I can rewrite, oops, this was 4/9, I'm sorry. I can put 4/9 over 27, can I, by multiplying by 3 over 3. So that means if I pull the x cubed out, I have 1 plus 8 27ths plus 12 27ths equals 5. That ends up to be oh, I'm subtracting. I am so sorry. That's a subtract. So 27 plus 8, right? This is 27 over 27 is 35 minus 12 is 23. So we have 23 for 27. X to the 3rd equals 5. X to the 3rd equals this 5 times, multiplied by the reciprocal, right? So x to the 3rd equals 135 over 23. And then this will be to the 1/3. This is kind of a lot of stuff going on here, huh? So if I move to the next page for a second, well, I'm going to go back actually one page. So if I found out that x is 135 over 23 to the 1/3, and I got that from the relationship that y equals 2/3 x, then I know that y equals 2/3 times this cube root. So this point would be an x of 135 over 23 to the 1/3, and then 2/3 135 over 23 to the 1/3. Wow, I hope you said he won't do this one. But it's doable. It was just a lot of work. Let's go back. All right, so we have two functions. The first one is f of x equals cosine of x, right, at 0. We're always talking about